With second generation 406 MHz distress beacons approved for use, you will see a mix of activated first generation 406 beacons, or FGBs, and second generation 406 beacons, SGBs, coming into the MCC for the foreseeable future. Both types of beacons send a distress signal when activated, but advancements in beacon technology mean SGBs can do so much more. First, let's recap first generation beacons. When an FGB provides a precise GNSS encoded location, the GNSS receiver in the beacon provides a location with a resolution of 4 seconds of latitude and longitude. As such, this location ends up being reported on a grid seen as a square with approximately 120 meter sides. So assuming there are no other errors, then the provided GNSS encoded location in the beacon message should be within plus or minus 85 meters, or half the diagonal of an 120 meter square for that decoded message location. Simply put, what you get from an FGB is an encoded location accurate to within about plus or minus 85 meters. Unfortunately, it does not indicate how old this position is or how close it is to the actual location due to the transmission lag of the message compared to the time the GNSS position was calculated. This uncertainty can increase the distance from the actual position anywhere from a few meters to a few kilometers, increasing the search radius, especially when beacons are moving. Let's look now at second generation beacons. With SGBs, the GNSS encoded location can be much more accurate. First, the resolution is 3.4 meters compared to the 120 meters for an FGB. So the SGB encoded location should be accurate in good conditions to within about plus or minus 3 meters. However, this isn't the main difference. It's what is in rotating field number 0 that makes all the difference for SAR. This includes the elapsed time since beacon activation to within 1 hour, the time from last encoded location to within 1 minute, the altitude of encoded location to within 16 meters, the delusion of precision, the DOP, and the remaining battery capacity. So what do these new pieces of information actually give us? Elapsed time since beacon activation is useful in 2 ways. If, for example, a beacon has been on and transmitting for 2 hours, but you just got the first MEOSTAR detection now, an antenna masking issue could be at play, i.e. cliffs blocking the view of the antenna to the satellite, maybe a person collapsing or debris falling on the antenna. And this possibly helps assess the level of trauma involved or the difficulty of the terrain at the distress site. Secondly, if the beacon elapsed time is, say, 23 hours for a PLB, then you know that the beacon may not transmit for much longer. Time from last encoded location tells you how old the position that's provided by the beacon is. This can be useful in places with a poor view of the sky or where something is potentially blocking the antenna. It can also be useful with a moving beacon, as it can help SAR services to determine a search radius, and can help when estimating drift rates and drift direction for beacons at sea, or for a backpacker trying to walk out. Altitude of location is very useful in mountainous terrain. If someone is in trouble on a cliff face, adding altitude to the latitude and longitude may help SAR services to determine if the person in distress is at the bottom of the face, halfway up it, or at the top. Altitude can also help if the locations, system generated and GNSS, provided to the SAR services in a SIT 185 are found to be confusing. SAR services can match the locations with the altitude provided and determine which location better matches the altitude. DOP, we've talked about before. It basically tells you how accurate the provided location is. Latin long for HDOP and altitude for VDOP. Eventually, the DOP will get converted into an estimated error circle, which is most useful for SAR services. A DOP of 1 equates to about an 8-meter location accuracy. A DOP of 5 equates to about a 24-meter location accuracy. Finally, remaining battery capacity is pretty self-evident. It is important to know how much longer the beacon is likely to keep transmitting. Kospa Sarsat. We save lives.